Okay, let's look at plane trusses. Since we have to design a truss, look at this truss. This is the way when you go to Walmart, you will see it at the top. We'll take most of the load from the roof. So we call this a roof truss. If you go to a bridge here, you can see that this is mostly truss. Most of the load gonna be going. Some of these members has no force in them, and they just to have it beautiful, to make it look like beautiful. So, but the members with the force, we need them because they will take some of the forces. If you put this here, you can see it like this. This is schematic of a truss in your class, statics. So the same thing here for the bridge, you can see it here. So now we're going to show you how could you analyze trusses. There's two methods. It's either joint method or a section method. Let's look at this example. Look at this example, and the angles are 60 degrees and 60 degrees here, 60 degrees, 1 meter, 1 meter, 1 meter, and there's a monkey swinging at point D. So there's a strong monkey swinging on the truss. The weight of that monkey is 3 kilonewton and at point D, which means that there's a force at point D. He needs to calculate the force induced in member AE. Look at this. He wants to know this force, AE. It's the same thing as the truss we just showed you, but he wants to know the force AE. And as I said, there is two methods, either joint method or section method. Let's do the joint method. So first of all, we'll determine the order of joints. Well, let's see. And then we'll draw a free body diagram. In the free body diagram, we have to show the whole truss. We don't care about the inside because we want to find out the reactions. Let's put it again. Let's put the truss again. Remember, this is a ruler. A ruler has one reaction up against the ruler. This is a hinge. A hinge has one reaction in the X, one reaction in the Y. So this is AY, AX, and this is CY in the Y-axis. And here there's a force. So we don't care if you want to find the reaction A and C, you have to ignore the inside truss unless you should see if there's outside. Like this force, we'll take this force only to get the reaction in A and the reaction in C. So let's look at the free body diagram. See, he did not include anything inside and he just put AY, AX, CY, and 3 kilonewton. Why he said that AX is equal to 0? Because if you do summation of forces at the x-axis, there is nothing in the x-axis. Y, Y, Y. So this is the only forces in the x-axis, so which means that AX is equal to 0. Summation of forces in the x equal to 0, which means that AX equal to 0. There is no other forces in the x-axis. Now, what is the next method? Is summation of forces at the x equal to 0. And the next one is summation of forces at the y equal to 0. Well, summations of forces at the y equal to 0, you'll have CY plus AY minus 3 equal to 0. Two unknowns and one equation. We'll leave that equation for later on. Let's find either summation of moment at A equal to 0 or summation of moment at C equal to 0. Okay? You can't take summation of moment at D equal to 0 because you will have CY and AY. You're going to have two unknowns and one equation. Let's get rid of one. Let's take summation of moment at C so we could get rid of CY equal to 0. So we'll do it like this. Summation of moment C equal to 0. If you do it like this, let's look at point C. This force AY gonna rotate clockwise. So AY times the perpendicular distance from C, 2 meters. So minus AY, look down. Minus AY times 2. What else? Else is this one, 3 kilonewton. And 3 kilonewton, remember, this is the perpendicular distance. Perpendicular from C, which is how much? 1 meter. Oh, no, it's not 1 meter. It is, you can see it here. If you do it like this, up. Okay, 1 meter is the whole thing from B to C. If you do it like this up, remember, this is 1, and this is up. So it's gonna be 60 degrees. So it's gonna be 1 cosine 60 is that way. So let's do it like this. This is 1 meter. 1 cosine 60 is this way, and 1 sine 60. We don't want this. We want this perpendicular distance from D. So this is 1 cosine 60. And that is the distance between D and C. So we'll do it. 3 kilonewton. And look at this. This is the distance. 3 kilonewton. Gonna go counterclockwise from C. And the distance from here to here, it is 1 meter. And of course, if it's like this or it's like this, it's the same thing. 1 cosine 60. 3 kilonewton, 1 cosine 60. Now you solve for AY, you will get AY is equal to 0.75 kilonewton, which means that we found AY. Now, let's say that AY is sufficient and we could find CY by doing summation of forces at Y equal to 0, and you could find CY because 3 Newton and AY is known. And because here he need AE. He need AE. So you don't have to go and find CY because it's not important. You could take joint A and that's it. It's sufficient. So let's take joint A. But you could find summation of force at Y equal to 0 and find CY, which is not important. But let's do joint A. If you take joint A, you'll have force AB, you'll have force AE, and you'll have the AY, 0.75. This is only at joint A. Look at joint A. Joint A. It has AB force, it has force AE, and it has the AY. There's no X. Well, we're going to assume it's tension. Tension will mean it's pulling the joint. We're going to assume that direction, tension. So I'm going to assume it FAB, and we know the angle is 60 degrees. Okay, now, we need to know, we don't need to know FAB, we only need FAE. So, what is the best method? The best method for this is not to find summation of force at x equal to 0, because you're going to make it hard. FAB is in the x, and FAE is also in the x. So the best is to find summation of forces at the y equal to 0. Because here, this is y, and this is y. This is not y. So let's do summation of forces of y equal to 0 now. FAE, that's cosine 60 in the x, sine 60 in the y. It's minus. So FAE minus FAE sine 60 in the minus, remember? This is FAE is cosine in the x, sine in the y. So FAE minus sine 60. And what else? 0.75 in the y plus. So 0.75 minus FAE sine 60, you could find FAY. And since it became plus, which means that our assumption is correct, is tension. So we could put 0.866 kilonewton tension, and that is the answer. Do we need to find FAB? You could find summation of force at x equal to 0 and find FAB, but he does not want it. And that's okay. That's good. Because here it's minus 0.433, and that is 0.433, which means that our assumption is not tension, it's compression. Compression means that it's pushing the joint. It's not pulling the joint. It's the opposite. But we should see it like this, 0.433 kilonewton compression. Well, there is no need to get this because the question was to find FAE. You could go back to the question. Is to find force, calculate the force induced in member AE. AE is this one. Thank you.